Okay, hello everyone. My name is Tong, and I'm here with Rutger. We're gonna talk about events, the events table partitioning. Let me share my screen. Share screen. Okay, does this look alright, Rutger?
Yeah.
Okay, cool. So basically the root issue is that the events table is big, very big. It's about 1 terabyte, I think. So quite big. Yeah, I'll try and find this one. Okay, so in this issue, we have all the data about this table. It's used in your user activity, project activity, group activity, contribution analytics. Yeah, those are the few places it's used. And it looks roughly like this. So the main use case is in this calendar here and the activity. So if you click on one of the cells, it will show you the activity for that day. And we only show 1 year's worth of data. So you can see later why this is important. Basically, it's all based on date based, and we only show 1 year's of data. I think like if you keep scrolling, you can see more maybe, but yeah, I think it's really hard to scroll 1 year's of data if you have a lot. Yeah, so that's the events table.
Is data removed after 1 year or supposed to be removed?
Data is removed after 3 years. So there's a
3 years.
sidekick, there's a background worker that removes old data that's 3 years old. But it's very inefficient. It only removes 10,000 events at a time. It will take 20 years to remove all the data that we have right now. So it's currently disabled on GitLab.com.
And do we archive it as well, or just
No,
delete it?
no, we just delete it. Yeah, no, that was a decision that was made years ago, like from almost the very start of GitLab.com. I think it's like if we don't need it, we delete it, right? Because nothing shows it. It's all 1 year, and we only show 1 year data here, right? So yeah, there's the idea anyway. So anyway, because this table is quite large, we want to kind of figure out how to reduce the size of the table, because a very big table like this is very hard to write to. It also costs money to store as well. A few $1,000s a month, but you know, it's not trivial. And it also very slow to read now as well. I think the crazy thing is that it's the data is only 100 gigabytes, but because it's so slow to read, we need like 10 times the amount of indexes just to read it efficiently. So yeah, so one of the great things about, I don't know, how much do you know about partitioning, Roger?
I know the high level that it's a Postgres feature, right?
Yes.
You can also implement it on the application level, but I think we use Postgres
That's right.
partitioning.
That's
So
right.
you set up from rule,
Yes.
and then most common use is something related to some timestamp or a date.
That's right. That's right.
Yeah, and
Yep.
then it will create like tables, but they are transparent for the application.
Yes. Yes.
So it is basically an how do you say, like an the main table will still be there.
Yes. Yeah.
But I think it will be renamed and then a new table will be added.
Yes.
And if you select data from that table, it will transparently read data from older tables if needed.
Mm-hmm.
Yeah.
Yep.
So that's the high level, right?
Yep.
Yeah.
Yeah, correct. Yeah. Yeah. That's absolutely correct. So it's been available since Postgres 10, I think, and then they progressively added more and more features. So since Postgres 12, it's pretty complete now, which is very nice. I think when they first introduced it, it didn't support like foreign keys and things like that, so made it really hard to use. But yes, that's the idea. So so the most obvious solution for the events table is to partition it. So behind the scenes, we'll have events for so the events partition for December 2023, or the events partition for January, February, and so on. So by month. By year, it's not enough, because if we split 1 terabyte by 5 years, say, it's still too big. So each partition is still too big. And then
And it's growing. There will be more events.
oh yeah,
So
yeah.
for in
Assuming
20,
we get more users, then
yeah,
the rate of growth will increase.
yeah.
So there'll be more events. Yes, that's very legitimate assumption. Yeah, that's what I assume as well. Yeah. So that's that. And then there is a guide that's very helpful that the database team has created. So I am mostly following that guide. So the step 1, 2, 3, 4. So there are correspondingly 2 issues that I've created, because this is one issue for release 1 and 2, step 1 and 2, and then the other issues for that. What else? Yeah, there's a lot of subtleties here. Oh yes, let's talk about other things. So other things that we could try besides partitioning is somehow drop some of these indexes, because this is 80% of the table is indexes. But I think we need all the indexes. So because this is
Well, I did see some how do you say, composite indexes that we can drop.
yes.
Because if you scroll up, an example is, for example, where your cursor is now, then one line up, that with the long name,
This one,
the
yes.
index right before that can also use. So queries against author ID and created ad can also run against that second index.
Yeah, that's true. So this
Yeah.
one, oh, but this is a partial when
Oh yeah. Oh
type
yeah, yeah.
is merge request. I see.
Well, there could be, yeah, but yeah.
Yeah. So maybe no. I think one of this is useless. Yeah, this one.
But yeah,
I think this one can be
but
deleted.
that will not. That is not a
Not enough.
long-term
Yeah.
solution.
Yeah, exactly. So we can delete things, but I think we'll probably only save a few gigabytes, and
Yeah.
we still have hundreds of gigabytes. So yeah, those are some of the things that I've considered. But yeah, the other thing that's a lot more drastic is that this is a polymorphic type table. It actually stores different, like 10 different types of events, right? It stores push events. It stores project events, like I create a project or I create a group, or it stores like project membership events, right? So they all have slightly different like logic. Yeah, slightly different logic to display things. So we could split it into 10 different tables.
Yeah.
But then to show anything, then we have to union across 10 different tables, and that's a horrible query as well. So I don't know. What do you think?
No, it doesn't give you that much because we do not. The access pattern is across all these target types, right? We just show all events for a given user or a given project.
Yeah, exactly. So
Yeah,
it
so
goes like that. Yeah.
yeah,
Which would be, yeah, if you want to build that query, it would be like,
yeah.
this one unit, that one, this one unit, or on an order by created ad,
Mm.
which is kind of expensive. Yeah. I mean, we could do something like that. We just need to change the UI UX, to something different. I think this doesn't show. Yeah, this doesn't show. But if you go to say the project activity, I closed that for no reason. You start to see that we actually have like different, which start to show by different event types already. But then there's this pesky all thing.
Yeah,
Yeah.
yeah.
So yeah.
Yeah, and another read performance optimization is to denormalize into based on the usage patterns. So you will have project events maybe that is accessed on the using project ID, and you can have another table like user events or something that is used for the my activity feeds.
Yes.
But that is actually duplicating data, because an event can be related to different. It can be, it can be on the project and on the user, right?
Right. Right. Right.
Yeah.
Yes.
If I create a merge request, it's both on the project and on the
And on the user.
and on me.
Yes. Yes.
But that is something that could be done, but it will basically triple your storage demand.
Yeah. Yeah. That doesn't save storage. That adds storage. So yeah. 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 Interesting idea. Yeah.
And other solutions are like using completely different storage
Oh yes. Yes. There is
outside.
one idea to use ClickHouse. Um, but ClickHouse is not available for self-managed yet, so that's not.
No, exactly. So then
Yeah.
you need to have complicated duplicate code for
For
self-managed.
GitLab.com. Yeah. Yeah.
Yeah.
Exactly. Yeah.
Yeah.
So the
So
the medium term solution is to partition it, as far as I can see.
yeah.
But there is still a long-term problem where if this keeps growing, I think even partitioning doesn't keep up, right? So we either need to start removing data or archiving data or something like that.
Yeah. But partitioning, deleting a partition is a very cheap operation. So we also
Exactly.
win there. Yeah.
Exactly. Yeah. So when we need to delete it or move the partition to somewhere else, it's very easy, right? Yeah. Okay. So what I've done is that I created issues to firstly so how they recommended we're doing it is that we create a copy of the table, and the copy is already partitioned, so it's set up the partition, and there is Rails code to automatically create the required partitioned tables. And then the second step is to copy the data from the old table to the partitioned events table.
Ah,
That makes sense.
yeah.
What?
It's a lot of data to copy.
Yes, it's a lot of data. Yeah, so if it's 1 TB and we take 50,000 rows per every 2 minutes, it will take many, many days. But apparently there's a new way of copying the data now using batch background migrations. So maybe you can parallelize this a lot more as well. So
Yeah.
maybe it'll take 40 days instead. Who knows? Which is nice. So that's that.
Can we also um, like since at some point we will delete the old data, that we only create use partitions for newly add data?
No. I mean, no, we can't. We need to completely copy everything first, and then we can start using partitions. So the idea
Yeah.
is that while this backfill is going on, I think it also creates a trigger to whenever data is inserted, it copies it as well to the new
Okay. Yeah.
table. Yeah. So it does that. And then the second thing is that what's this? This is step 3 to clean up, to just throw away the background migration, and then step 4 is to basically swap the two tables around. So that's the thing. Okay, let's go back to here. So the thing with partitions, the trade-off with partitions is that yes, it's good, but if you want to query data across two partitions, say I want data from January and I want data from February, it's very inefficient to do that. So ideally, every single query that we have has the created add thing inside the query, or what I call the partition key. So there's a few ways of getting all the queries that the application generates for this, and it mostly has the created add thing, but not everything. So one of the issues that I've created is to go change all the queries to having created add inside, so that it will be efficient when we switch to partitions.
Yeah. And I've also used in the past a index on a function. You can do that in Postgres on because timestamp indexes are huge because almost all values in the created data are unique. You know, they are microseconds.
Yes.
But if you, well, in my case, I could use date. So I had an index on date created at,
Mm-hmm.
and that index is updated when you insert or update a record.
Yeah.
And then I could query that to have a very small index for that would give me everything for a certain date. And then I would, narrow it down on something. So
Right.
like
Right.
so
Right.
I had where date created at equals or is between or whatever,
Right.
and project ID is or author ID is,
Yes.
and then the index becomes more
Yes.
small and faster.
Well, yes, that is true. I think the good news is that Postgres does this automatically for us, which is really, really nice. Um, not sure about indexes, because I think you need to have the partition key as part of your primary key. So
Oh,
yeah, so
yeah.
your primary key now becomes ID and created app. So it's already part of the index. 'Cause it's already part of the primary key. But I think what Postgres does is that it takes the created add, and then it in the background it does something like an index, but it's not really an index. I can't remember what they call it, but it converts that into like the hash of the partition that it's looking for. It's like, hey, okay, I'm looking for the month and the year of the partition. So it
Yeah.
will naturally throw away the time, the hour, the second, the things, and then it will query the right. It will look for it in the right partition table. So we don't need to have special indexes for that. To look for the right partition. If you get what I mean? Yeah. I think
Yeah,
maybe
because
because
the
it's
partition will be on year and month, right?
yes.
Yeah.
Yeah. So we don't need to create another additional index for that. Postgres naturally does that already, which is super nice. Yeah. The good news about all these queries is that I think a lot of queries already go order by events.id. So it should be quite easy to, hopefully it's quite easy to convert the order by to order by events.created@, events.id. So I think, yeah, I think. So that's where is it? That's
Okay.
that's this one. Update queries. So yeah. I should probably copy that over. Queries C. Oh yeah, that's such a very small link. Yeah, I should probably update this because it's analysis of queries to. It's not very clear. Okay, there we go. Okay. You following so far? Okay. No.
We have 5 minutes left.
Yeah, exactly. Yeah. So let's speed things up. So there is another table which is for that table's foreign key refers to the events table, but that one's only 200 gigabytes. So let's not talk about that. Let's talk about the last complexity here, which is that we have a unique index on the events table. But the unique index doesn't have created at. So which means that Postgres will not allow this unique index when we partition it. It's just part of the rules, I guess. It's too expensive to have a weird unique index like that. So I think we can't drop it because we'll still need it. So I think what we need to do instead is to do this, which is move some of the data into a normalized table, and then so that we can keep querying that data. I think this is the most complicated bit. I think the other bits are slow, but yeah, but still manageable. This one I don't know. But yeah, this one I'm talking with Adam. On this one.
Is this like to guarantee uniqueness?
I don't know what it does exactly. Like, yeah, maybe. I think it's because like wiki pages, like when we create a wiki page, it also checks into the repo and it does it slightly differently. So yeah, I'm not sure. Yeah.
Okay.
Anyway, any
Is there
questions?
yeah, this issue says that which will have the following columns, but then fingerprint
Fingerprint?
move the fingerprint column to a new table. Oh, okay. Yeah,
Oh,
sorry. I'm a bit
other
confused.
columns as well. Yeah.
Yeah. Okay.
Yes. Yes. Move and well, yeah.
And are there any since we will create a new table for the events,
Yes.
are there any other opportunities for because now we start with a new table, there's
Yes.
also the chance to maybe optimize something.
Yes. So we can reorder the column order.
Yeah.
So I've put it as a note in one of the issues when we create a copy. So the current table order is not efficient. It wastes 24 bytes per row. So 24 bytes times 3 billion. It's a few gigabytes. So if we can save those 24 bytes, we can save 40 gigabytes. So yeah, there we go. Definitely should do that.
Yeah, and the target type stuff, but that's a string.
Yeah. Do we want to do that? It
Well,
might complicate the backfill though. So yeah.
yeah, and I would only do that if Rails polymorphic association can support changing it to an enum or something like that.
Yeah, it can. The problem is that I don't know how the backfill works, because you now have to do transformation when you do backfill, because the new table is going to have a different data type, and then the old
Yeah.
table is going to have
Yeah,
a different data type. So I don't know how the backfill
yeah,
works in that sense.
yeah.
Yeah.
It's mostly storage I'm thinking about.
Yeah.
Doesn't give you much for the performance. It doesn't really matter.
No. Yes, definitely.
Oh,
Yeah, if you can save some storage, I think I would as well.
yeah.
As long as it doesn't complicate the backfill.
Yeah.
Okay, I think we're at time. So thanks very much.
Yeah. And
Yeah. We'll
let's
chat more
switch
later.
to that. Yeah. Bye.
Stop recording.